So here we are given a function f of x, and we say that's equal to sine x. And we're given another function g of x, and that's equal to the square root of x. So what they're wanting us to do is say, hey, what does the expression look like for this thing called y if we go g, and then instead of just writing an x, we're going to write what f of x is inside that. So instead of just grabbing that value of x for the g, we're going to stick in this thing, that sine x, into there. So let's give it a shot. Let's do it. Well, we start off with the square root, and instead of writing x, instead we're just going to put sine of x. And hey, that's it. That's your answer. Boom, 2 marks. Let's go on to part B. Okay, so they want you to find dy dx of that thing. So now that we know that y is equal to the square root of sine of x like that, let's differentiate it. So dy dx, okay, now that looks kind of horrible, doesn't it? That looks like a function within a function, which it is. So let's start off with something simple. Let's find the derivative, okay, of the outside function, just g of x, so the square root of x. Well, that is like saying find the derivative of x to the power of 1/2. Now, it's always so much easier to write it as a fraction in the indice. So x to the power of 1/2. What we do is we take that half, we put it down the bottom, and we take 1 from the top. Now that looks a bit funky, right? But what is 0.5 minus 1? You might say that's 0.5, negative 0.5. So let's do the same thing. What is 1/2 minus 1? But let's not write 1 like that. Do you agree with me that 2 divided by 2 is 1? And then do you agree with me that this is equal to 1/2? So there we go. That's the outside bit. That's what it's equal to. So we can say that when we differentiate that, or if we have g prime of x, we are equal to 1/2 x minus 1/2, like that. Cool. Now, what we want to do here is we then want to chain this together. So you might have heard of the chain rule, right? So you might have seen it written like dy dx is equal to this thing called dy du, whatever that u might be, and then dx, like that. So the way that I like to write it is that this function g f of x, if I differentiate that, that is equal to g differentiated times by that f being differentiated. So what we found on the outside, first of all, which I'll do in red, okay, that is this bit here. That is this bit here. But we also need to times it by the guts of it. What is sine differentiated? Okay, so that's the next step, and that's our bit in yellow here. I'll use yellow or orange for this bit, and also for this bit here. So in this case, if we try and differentiate f prime, right, the sign will go from being a cos, so the sign will change to a cos, because they're quite intricately linked. And then you've got to decide if there's a negative or not. Okay, the easiest way that I remember this is DC comics is worse than marble. So if you differentiate cos, you get a negative sign. If you integrate sine, you get a negative sign. But in this case, we're differentiating sine, so there's no negative. And this is, in fact, our yellow bit. And we multiply them together. So our final answer with all of that is going to be that dy dx is equal to All right, that 1/2, and then this sine of x to the power of -1/2. Okay, so I only showed you it with this guy here being an x, but we want to keep that the same. So leave it like that, and then we times it by cos of x. Now, whenever you have a negative indice, it means that it should be at the bottom of the fraction, not at the top. So that should be 1 sine, like this. All right. Oh, not a negative there, just 1/2 there, and the cos at the top. So I'm just making this look neat. You probably don't need these steps, but I just want to put it in anyway. So the cos goes at the top. Okay, so when you have something like 1/2 times by 3 divided by 4, that's equal to, you can imagine the arrows point to each other, right? And we get the times across. And so that's 2 times by 4, 1 times by 3, and we get that as 3 times divided by 8. Okay, so the same thing happens here. And then that's all the square root of sine of x there. Cool. So that's not the whole answer. It is asking us to find the value when x is equal to 90 degrees, so pi on 2. So we have to then substitute that into all of it. So we've got to evaluate this thing. Whoa, that looks hard. Let's break it down. Let's make it so much easier. There are two trig equations that we're gonna need to solve. So first of all, cos at 90 degrees, pi on 2, and also sine 90 degrees, pi on 2. All right, let's draw a unit circle. All right. Cos is crawling the x-axis. Sine is touching the sky, the y-axis. All right. So what happens if we go around 90 degrees and we stop here? It's a unit circle. And so what we say is that the point is 0. You haven't gone along the x-axis, you haven't crawled anywhere, but you've touched the sky at 1. And that's our answers here. So for cos, it's going to be equal to 0. And for sine, it's going to be equal to 1. Okay? And so hopefully that makes it a lot easier. Let's substitute those values in. All of that becomes 0. All of that becomes 1. Now, I can simplify the bottom bit for you, but like realistically, the thing on the top, the numerator is 0. So let's say you've got a briefcase. That's your denominator. That's the thing down the bottom. All right. If you've got nothing in your briefcase, you've still got nothing. You've got no dollars, even if it's a bigger briefcase. You've got $0 in a gigantic sea container. You still got $0. So all of this is equal to 0. That is our answer. That's our final answer there. Cool. So now let's try and find the next part. So part C here. C is saying, hey, can you find dy dx? Find that for me. Okay, if y is equal to sine, and now it's the opposite way. We've got the square root on the inside. Okay, so we can make this nice and easy. We can see there's the function on the outside. I'm just going to call this, actually, I'll do it the proper way. I'll say let u equal to the square root of x. Okay, so therefore we have y is equal to sine of u. Okay, and this is why you get your dy dx is equal to dy du. So you differentiate this thing in red with respect to u, and that gives you this bit. And then you also have to differentiate this thing in yellow with respect to x, and that gives you this bit here, du dx. Okay, let's find each of them individually. So first of all, what is dy du? Well, that is equal to, remember, the sine goes to a cos when you differentiate it. So it's a cos. And we're just going to write u here. Now you got to figure out, is that a negative sign or a positive sign? When you differentiate cos and you integrate sine, so DC Comics is worse than Marvel, right? Then you get a negative on both. So are we differentiating cos? No, we started and we differentiated sine. So we ended up with cos. There's no bit there. So we've got the red. Now just remember you've got to substitute out that u, because if you write a u in there, that wasn't the original question. But the next thing is we've got to find the dx for that value of u. So u is equal to the square root of x. So du dx, and that is equal to, just like saying x to the 1/2. Okay, so put the 1/2 out the front and then minus a half from it. Now, that you might be able to say is 0.5 and minus 1 is equal to minus 0.5. But we want this in fractions, so let's use this. Let's say it's minus 1, but let's not write the 1 as that. Let's write it as 2 divided by 2. You can see that that is equal to 1. And you can see that 1 minus 2 here is equal to minus 1/2. Cool. So therefore, all we can say that all of this is just equal to 1/2 and then x minus 1/2. And that is our yellow. Okay, let's put it all together. Finally, let's say that dy dx is equal to, right? That is equal to cos on the square root of x. So instead of writing u there, we're going to write the square root of x. And then we also have to times by 1/2 x minus 1/2. Okay, and let's simplify this. Let's make it look a little better. Okay, if you have like 3 to the minus 1, by the way, that is equal to 1 divided by 3. Okay, see how it flips it across the fraction line there. So in this case, we're going to do the same thing. We're going to write cos normally. And we're going to put the x down the bottom along with the 2. Now, anything to the power of the half, we've got a nice symbol for that. We can write that as the square root. Voila, that is our answer. So I've got so many more questions like this on my website. Visit it. I would love to share it with you. If you do it all, you likely get really good marks in your exams. They're all tailored to be towards the WACE curriculum. So yeah, you get really good marks. And if you have any questions, reach out. Hey, I'd love to help.